Whether natural or mechanical exhaust is being used, when the exhaust points are within a short distance of the edge of the reservoir, generally 2 metres, there is a different and slightly older model that is used. In such a case, the movement of smoky gases beneath the exhaust point may be different to the movement beneath the exhaust points that are further from the edge of the reservoir, so the different model is used to calculate M-crit. The model is shown here. This is, as stated, an older model than the one we've been looking at, but it does remain the most accurate that we currently have for this scenario. We use this model, or another one that we'll look at shortly, when the exhaust points, the fans or the vents, are less than 2 metres from the edge of the reservoir. Perhaps, for example, they might be situated vertically at the edge of the reservoir as shown here. Take care which model you choose to use though. In this similar scenario, it might be more appropriate to use the model for vents that are more than 2 metres from the reservoir edge. Here is the model we use. As you can see from looking at the equation, it has many of the same variables as the previous model for vents or fans that are more than 2 metres from the reservoir edge, but it does not involve rho naught, and more significantly, it does not involve WV, the diameter of the vent or fan. Intuitively, you would believe that the size of the extraction point is likely to have an effect on whether or not plug holing occurs, but this is one of the best models that we currently have for this scenario, and until something better comes along, it can provide us with reasonable predictions for the onset of plug holing. As mentioned just now, there is an alternative to this equation for exhaust points within 2 metres of the reservoir edge, and this alternative is shown here. It is simply to use the first model we looked at and to multiply the result by 0.7 or 70%. The latter model is proposed by PD 7974 Part 2, whilst the former is given by BR 368. As we're using this model to find an upper limit, and as we accept that they do not give precisely determined results but only indicative figures, it may be worthwhile using both models to get a feel for where the true upper limit lies, and then looking to see how much smoke is actually coming out from a single exhaust point to ensure that this is well below the limit M-crit. Returning to the first equation for exhausts within 2 metres of the reservoir edge, we can see that D, the depth of smoke in the reservoir, has, as we would probably expect, a highly influential role to play in evaluating the result. D is raised to the power 5 and then to the power 1/2, giving it a final index of 2.5, which is slightly greater than its square. So D is the most influential variable, whichever model you choose, and you'll find from experience that a depth of smoke of, say, less than 1 metre will more often than not plug hole, whilst a depth of smoke of 5 metres will never plug hole. That concludes step 9, and now we want you to perform some exercises.